Hello, this is Swati Shrikmar and the lesson is on experimental methods and least count, part 2. We will be seeing how to determine the value of G using a simple pendulum. We know that the period T, time period, for a simple pendulum does not depend on the mass or the initial angular displacement. Instead, it depends only on the length L of the string and the value of the gravitational field strength G. According to the equation, T is equal to 2 pi into root of L by G. So the principle for this experiment is that let the time period of the simple pendulum be given by time for n oscillations by n. N can be any number, like it could be 10 oscillations. The time taken for 10 oscillations divided by 10, or 20, the time taken for 20 oscillations by 20, etc. So it is according to u. And so we can equate the two equations. By this equation we can find out the time period which can be substituted here. L can be measured because it is the length of the simple pendulum, and G can be found out or calculated using this equation. This is the modification of the equation we saw before. That is, here both the sides are squared. After squaring, we will be getting T square is equal to 4 pi square L by G. So here the G is moved to this side and the T comes here, giving us G is equal to 4 pi square L by T square. So the length of the pendulum is measured, then the pendulum is set under motion, and after it completes n number of to and fro oscillations, the time is recorded for the same. Using these informations, we can calculate T, which is the time period. Then different values of T are taken with different length of the pendulum. That is, for each length, around 5 values of time taken will be noted down, and the average is used, and these values are then substituted to find the value of G. So this is the experiment which is used to determine G using a simple pendulum. Moving on. Ohm's law using voltmeter and ammeter. How can we prove it? We know Ohm's law states that there is a linear relationship between the voltage drop and the current flowing through it. Therefore, the resistance R is viewed as a constant independent of the voltage and the current. And we get the formula V equal to IR, where V is the voltage applied across the circuit, which is in volts. I is the current flowing through circuit which is in amperes, and R is the resistance of the circuit in ohms. So let's see what is ohmic materials. The materials obeying this law, the Ohm's law, are known as ohmic or linear materials because the potential difference across it varies linearly with the current. Now we know that resistance can also be expressed as R is equal to rho, which is the resistivity of any material, into the length of the material divided by the cross section area A. Moving on, here the symbols used are, this is the symbol for resistance, this is the symbol for voltmeter, and this straight line is used for the connections and wires. That is a conductor with negligible resistance. The resistor is made with a specific value of resistance between its end. The voltmeter measures the potential difference between its terminal, that is the potential difference between here and here. Ammeter, this ammeter measures the current that flows through it. So a voltmeter is a device used for measuring the potential difference between 2 points in an electric circuit, as we saw earlier. And an idealized voltmeter has infinitely large resistance and measures potential without having any current diverted through it. So the current flows through here so that you can find out the potential drop across these two places due to the resistance under study. Moving on, an ammeter is used to measure the flow of electric current in an electric circuit. An idealized ammeter has zero resistance and has no potential difference between its terminal. That is, ammeter should have almost zero resistance, otherwise the current would not flow through this. So this is the circuit diagram for studying the Ohm's law, that is when a high resistance is used. This is when a low resistance is used. We can see that here voltmeter is parallel to both A and the resistance. Here voltmeter is parallel to the resistance, and this is parallel to the ammeter. This is the circuit diagram for Ohm's law, the general form. So here what is done is, when the current flows, the current is noted down. Electric current is noted here using the ammeter, and the voltmeter is used to note down the volt or the potential drop across the resistance, and so we will get the values I and V, with which we can calculate the value of R or the resistance. So that was Ohm's law. Thank you, and with this lesson course 1 is completed. Thank you once again.